In this video, you're going to learn about extrema on an interval. You'll also learn how to do the following things. The first is to know what the heck extrema is. An extremum is another fancy word for a maximum or a minimum. So when you see the word extrema, that's plural, that means maxima or minima. So we're talking about like how high or low a function can go. There are two types of extrema. There are relative extrema and absolute extrema. In this video, we're mainly going to focus on absolute extrema because relative extrema will come a little bit later. You'll learn what a critical number is and why they're critical to calculus. And we'll learn something called the candidates test, which is a test to find absolute extrema. Yay! Like I mentioned before, there are two kinds of extrema. There are relative extrema and absolute extrema. There are some similarities and differences between the two. For one thing, both of them must occur at a point. So they can, So must occur at a point. And furthermore, relative and absolute extrema can only occur at endpoints or at critical numbers. Like that. Well, you might be asking yourself, why did I label endpoints in blue? Well, the reason I labeled endpoints as blue is because endpoints can only be absolute extrema. So, I need to say this correctly. Endpoints can only be absolute extrema, but not every endpoint has to be an extrema. So, for example, if you have a function that looks like this, clearly the endpoints are not the maximum and minimum because that's the maximum and that's the minimum. Now let's talk about critical numbers, because I've talked about them a lot but haven't actually said what they are. A critical number is an x value on a function, so it's a value x equals c, where the derivative of f, so f prime of c, is either equal to 0 or undefined. And so basically this is wherever we have a horizontal tangent line or an undefined derivative, which could be a vertical asymptote or a sharp turn. So it's either a vertical asymptote or a sharp turn. Also note that a critical number is not an endpoint. So even though the derivative, even though endpoints are not differentiable, so they do fall into this category, for our definition, the critical numbers are not going to include the endpoints. Critical numbers are important because they help us to figure out where relative extrema are. So relative extrema can only occur at critical numbers, but not all critical numbers are extrema. And I'll do a couple examples at the end to highlight the differences between critical numbers and endpoints and relative and absolute using some graphs, because that'll be a little bit easier. To find absolute extrema, we're going to use something called the candidates test. This is only for absolute extrema. And basically what we do is we make a list of all the possible candidates that could be absolute extrema and then find the y values and see which one works. So remember that absolute extrema can occur at both endpoints and at critical numbers. So what we do is we make a list of all the endpoints and all the critical numbers of the function on the interval. So we'll start off with an easier example. Let's say we have y equals x squared on the interval from -1 to 3. Alright, that's our complete graph. We have two endpoints. We have -1 and we have 3. And notice that the function includes both because they are closed brackets. And we need to find, let's say we want to find the absolute maximum and the absolute minimum of this function. Well, we're going to use the candidates test. So we make a list. We do the x values and the y values. And so we start with our endpoints. We have -1 and 3. Great. Those are the endpoints. Then what we need to do is we need to find all the critical numbers of this function. Well, we start by taking the derivative. Y prime is 2x. Then we take our derivative and we set it equal to 0. So we take our derivative and we set it equal to 0. And we solve it. And we get x equals 0. So this is our critical number, and this goes in our candidates test, right there. And then what we do is we just find all the y values. So we take y equals x squared, and we plug them all in. So we get 1, 9, and 0. So the candidates test is really easy because now all you have to do is you have to find the biggest number and the smallest number. The biggest number is 9, the smallest number is 0. So this means that 9 is the absolute maximum and 0 is the absolute minimum. Just like that. Let's notice a couple things. First off, we used this endpoints in the candidates test, but it didn't show up, or it didn't turn up to be one of our extrema. That's okay. That can happen. Remember that the endpoints can only be absolute, but not every endpoint has to be an extrema. So for example, this right endpoint was the absolute maximum, but the left endpoint was not, because this one, the right one, is higher. And then we have this point down here, which is the very bottom of the function. This is where we have our horizontal tangent line. That's why we used it, because it's a critical number, because its derivative is 0. And then we plugged that in, got 0, and that is our absolute minimum. We're going to look at a slightly more difficult example now, and this example will show how critical numbers don't need to be extrema. So we need to find the maximum and minimum values of f if f of x equals 3x to the fourth minus 4x cubed on the interval -1 to 2. When you see this language, find the maximum and minimum values, oftentimes the word absolute won't be explicitly stated. This means absolute. And because we're finding the absolute maxes and mins, we need to use the candidates test. So we'll start off with our x and y chart. Here it is. We'll start with our endpoints. We have -1 and 2. And then what we need to do is we need to find the critical values. So we take the derivative of f, and we get 12x to the third minus 12x squared. Now we're going to set it equal to 0. So when I do this, oftentimes I like to replace x with c so that I remember that I'm finding critical numbers. So we'll do 12c cubed minus 12c squared. We'll factor out a 12c squared out of both terms, and we'll be left with c minus 1. That means that the two critical numbers are c equals 0 and c equals 1. So I put them over here in my candidates test. And now it's the easy part. All I have to do is just plug each of these numbers into the function. When you do that, so you'll do like 3 times -1 to the fourth minus 4 times -1 cubed. This is -7. Okay, if you go through these and calculate them all, you get, no, it's not -7. It's +7, Mr. DRAM. Seriously, do your math right. You'll get 7, 16, 0, and -1. Great, we're almost done. This is the biggest number, so this is the maximum value of f. So when it says minimum or maximum value, we're looking for the actual y value of the function. So even though the value occurs at x equals 2, the actual value of the function there is 16. So 16 is the maximum value. And -1 is the smallest number we have, so this is the minimum value of f. And remember that both of these are absolute because they are the absolute maximum and the absolute minimum of f. Just want to point something out here. We did have two critical numbers. We had c equals 1 and c equals 0. But with c equals 0, we did not get an extrema because that can happen. Okay, it's okay for that to happen like that. One more quick example to highlight where else we could have critical points. Let's say we have this function, and I'll just draw a graph of it. So this is some weird piecewise function. Let's say we have the point 0, 5, 5, 0. This is going to be 9, 4, and this will be 13, 5. That's a 3. So 13, 5. And we need to find the absolute maxes and minimums of this function. So we start with our endpoints. Our endpoints are, so we make our xy chart. Our endpoints are 0 and 13, and the y values of each of these are both 5. Okay. Now we need to find our critical numbers. Remember that critical numbers are where f prime of x equals 0. Does that ever happen? No. But remember that the other definition of a critical number was where f prime of x was undefined. And we had to remember where you could have an undefined derivative, and that occurs at sharp turns. you have a sharp turn there, so one of our critical numbers is x equals 5. And you have a sharp turn here, so one of our critical numbers is x equals 9. And then we plug in, or we find the y values at each of those. The y value at 5 is 0, and the y value at 9 is 4. So that's the end of our candidates test, and now we basically pick the biggest and smallest values. Well, the biggest value is 5. It's okay that it occurs twice. So technically, yes, you could have 2 points that each have the same maximum value. That's fine. And then 0 is our minimum, so this is our absolute minimum. And 4 is just kind of hanging out, because it's neither a maximum nor a minimum, even though it's a critical number.